morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are talking about trigonometric relationships, trigonometric identities. Extremely exciting. We got Olivia Newton-John going. Let's get to it, shall we? So, first thing I want us to consider is to find the values of these particular expressions. And recall, sine squared theta is actually sine of theta squared. This is just a notation that we use. So let's find sine squared pi over 6 plus cosine squared pi over 6. Well, hopefully you know that sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. And if we square those, we're going to get 1/4 plus 3/4, which is equal to 1. So 2 pi over 3, well, sine of 2 pi over 3 is root 3 over 2. Cosine of 2 pi over 3 is negative 1/2. And we get 3/4 plus 1/4 is equal to 1. Coincidence? We'll see. 7 pi over 4. Sine of 7 pi over 4 is negative root 2 over 2 squared. Cosine squared of 7 pi over 2 is root 2 over 2 squared. That's equal to 2 over 4 plus 2 over 4, which is 4 over 4, or 1. Sine squared 3 pi over 2. Well, sine of 3 pi over 2 is negative 1 squared. Cosine is 0. Well, that's going to be equal to 1. Seeing a pattern here. All right, so sine of 2 pi is 0. So 0 squared. And then cosine of 2 pi is 1 squared. And that is equal to 1. So clearly we're seeing that all of these are equal to 1. Notice it's the same angle that we have used in each of these expressions. What I mean by that, it's the same for sine and cosine in each individual expression. So make a conjecture, that should say about the value of sine squared theta plus cosine squared theta. Well, hopefully you're going to say, all right, sine squared theta plus cosine squared theta is equal to 1. Okay, well, let's think about that here in our unit circle. Our unit circle has a radius of 1. So let's put that in there. Okay, so no matter where I am, I have a radius of 1. Yes, and if I draw lines to form a right triangle, let's see, I probably should have come straight down first. Let's do that. So come perpendicular to the x-axis, then we'll go over here, okay, and form a right angle. And remember, this is our x and value, and this is our y value. So we have the coordinate xy, which we already know is equal to cosine theta. If I call this theta right here, sine theta. They are equivalent. Those are my ordered pairs. So clearly we have a right triangle and we have an hypotenuse. So x squared plus y squared must equal 1 squared, which is 1, which means that cosine squared theta plus sine squared theta, which is the same as this, we just commuted the property of addition, is equal to 1. So there's an algebraic geometric proof that we have the relationship among sine squared plus cosine squared is equal to 1 with our good friend Pythagoras. Okay, so that helps us quite often. Trigonometric relationships or identities. Sine squared plus cosine squared is equal to 1 is one of them, and tan theta is equal to sine over theta. Also with this relationship, a little bit of algebra. If I subtract cosine squared from both sides, I get sine squared equals 1 minus cosine squared, and similarly cosine squared equals 1 minus sine squared. So when we get into some nasty trigonometric equations, that can help us. So simplify, this is easy. 3 cosine theta and then another 4 cosine thetas is equal to 7 cosine theta. That's no different than 3x plus 4x equals 7x. You're used to this. It's just instead of x, we have cosine or sine. Tangent alpha minus 3 tangent alpha is equal to negative 2 tangent of alpha. Again, just like x minus 3x equals negative 2x. No difference there. What if I have this? Well, 2 minus 2 sine squared theta. Well, I notice I have two terms, both with 2 in it, so I can factor a 2, and this becomes 1 minus sine squared theta. And if you recall, let me just write over here, cosine squared theta minus sine or plus sine squared theta is equal to 1. So if I subtract sine squared theta from both sides, I get 1 minus sine squared theta, which is exactly what I have here. So that is equal to cosine squared theta. And so we end up with 2 cosine squared theta. Clearly, 2 cosine squared theta is simpler to deal with than 2 minus 2 sine squared theta. Okay, what about here? Well, here we have sine theta in common, so I can factor out a sine theta. And the first term, that leaves me with cosine squared theta. Oh, look at the beauty that's about to happen. Factoring out a sine theta here gives me sine squared theta. Cosine squared plus sine squared is equal to 1, which is equal to sine of theta. One more little example. Expand and simplify. All right, so this is equal to, remember, a minus b, the quantity squared, is equal to a squared minus 2ab plus b squared. Or if you just if you can't deal with that, a minus b squared is equal to a minus b times a minus b. And you can just expand using the acronym FOIL if you would like. I'm going to use this method right here. It's clean and it's easier. So we would end up with cosine squared theta, because this is A, this is B, minus 2 sine theta cosine theta, AB, I went ahead and did BA, plus sine squared theta. And let me put a little line here to divide this up. Well, I've got cosine squared plus sine squared is equal to 1. So that is 1 minus 2 sine theta cosine theta. Okay, so we expanded it, and then we made the expansion a bit simpler. You could argue, okay, this form is simpler than this, but there is going to be times when we need to expand a trigonometric expression to make it simpler. All right, a little bit of an intro into trig identities and relationships. I hope you enjoyed it. In fact, I'm sure you did. I did, certainly. And with that, I am out! I have to say, that just